value of the function fx. And it will be equal to square root x when x greater than 1. That's the right limit. Okay. Now analyze the function is continue at x equal to 1 or not. Let's finding the fx first. They're all 1, isn't it? Yeah, fx will be equal to 1 for sure. How about the left limit? Limit of fx when x approach 1 from the left. It will be 3 over 1 plus 2 minus 1, right? 3 over 3. 3 over 3. Yeah, will become 0, right? This is become 0. Again, now the value of the functions and the left limit is not the same. Then we can set it immediately. No need to check for the right limit. This is discontinue. Again. We check like this. When you say, it must say like, okay, this function it discontinue at x equal to 1, right? Because in the other point is maybe continue. Okay? This is important to write. Like that. The third one almost the same. Check the left limit, check the right limit, check the function. I check the function first. This is fx equal to 1 again. Well, you get 1. f1. f1 equal to 1. I don't think it's 1. fx, right? fx is f1. We check f1. But when you're looking for f of 1, we're going to use this line. Okay, use this line function because it says less than or equal to 1. Then we had minus 2 times 1 plus 3 times 1 plus 8. Is that equal to 1? This is equal to 9, right? Square root 9. Then it will be 3. Because it's minus. Minus 2 times 1 power 2, you get minus 2, right? Minus 2 plus 3, you get 1. 1 plus 8, you have 9. This is the value of the function and also the left limit. Okay? If we're looking for a limit of fx, when x approach 1 from the left side, this is the same to f1. Now we get 3. Okay? Now we check again with the right limit. Okay? To the right limit. Limit of fx. X approach 1 from the right. Now we use the second function here. It will be minus 9 times 1 divided by 1 plus 2 and then plus 6. Minus 9 over 3, then you get minus 3. Minus 3 plus 6, you have 3. Okay, left limit and the right limit are same. The value of the limit equal to the value of the function. This is continue. Okay. Then the question 3, we said that our function continue at x equal to 1. Like this. Number 2 is discontinue. Number 1 is discontinue. Because like f1 equal to 1, but limit of f1 from the left equal to 0. That is not the same now. It must be the same number, then we can say that this is continue or discontinue. Right. Number 6 lah. 5 or 6 or 4? 4 is discontinue. Good job. How about 5 though? Continue or discontinue? In the question 4, we check the same thing. You find f1, you find f3 first. Okay? Because it say when x equal to 3, we check for the f3. If you're looking for f3, where is it? It must be here because less than or equal to 3, right? That's a minus 18 times 3 divided by 3 plus 3 and then like plus 10 right there. Then we calculate the number. 4? Really? No. What, we get 4?
It's over 6.
Yeah, it's over 6.
ข้อ5 discount เนาะมันต้องเป็น60เลย
It's like, it's what? Isn't it? This is what? X and 3 like 48 minus 48. Minus 48 divided by 6 is minus 8, right? Or 1. It is 1, yeah. It is 1. For this. That's like 54, right? Then this will be like 1, okay? F3 equal to 1. Your job, check the left limit and the right limit. Right now, like for the left limit, we don't need to check because normally this question like left limit and the value of the functions, F3 are same. Then F3 and the left limit of fx when x approach 3 from the left side equal to 1. Check the right limit. The limits of fx when x approach 3 to the right side, it will be 3 over 3 minus 2 and then minus 1. Do we have the same number? It's no, right? This is equal to 2. You will see that the value of the limits, I mean the value of the left limit and the right limit are not the same and also different to the value of the function. This is discontinuous. All right. I leave one question for you. The question's fine. Then you can check it by yourself. Okay? If you're not finished taking note this one, please finish taking note this one. 5 is what, baby? Discontinue. Good job. The way it is. Not that hard, not that hard.
พอแล้วเอโจไม่สบายเลย
Why?
คือเอโจเหมือนเป็น
Say half.
มันแรสปี้นิดนึง
ใช่ว่าใช้เสียงเยอะ ช่วงนี้จริงก็ใช้เสียงเยอะทุกวัน ก็เลยเจ็บคอ ก็เลยไม่อยากตะโกน ก็เลยต้องเอาอีกเครื่องนี้มาด้วย แต่มันจะเล็กไปสำหรับห้องนี้ต้องซื้ออันใหม่ ฮะ
เป็น12ดีกว่า7 วันนะ7 วันเดือน
alright ชิชาแปลว่า how about Central World
เกิดมากค่ะได้คุยกับเรื่องทักษิณด้วย
อ้าว
ก็ได้เจอคณะบดี
ฮะดี
แล้วก็ได้เจอผอ.สพท.ด้วยแล้วเขาบอกว่าเขาจะพาพวกหนูไปอัดรายการแล้วก็จะส่งเรื่องมาที่สพม.ขอนแก่นก็แบบว่าพาไปที่นั่นแล้วก็จะเผยแพร่ไปโรงเรียนทั่วประเทศจริงไหมเนี่ยเขาบอก
perfect good job เลิศ
ได้เจอคุณลุงซีเครตคนหนึ่งได้เจอคุณลุงโอ้ยอะไรอ่ะเขาจะไม่มีภาษาจริงๆแล้วเขามีแต่มันพัง
next phrase Next phrase, we're going to talking about the differentiation or the derivative of the functions. All right. Normally, the way that we're finding the derivative of the function, it is we use the limit theorems and find the changing from one value to another one value. But that change is really small. Okay. Right now we are on the page 60. Normally, like the basic, super basic things about the differentiate it before that. It's from here. Let me explain. From the page like 57. 57, the theory say that if we want to find the derivative of the function or the differentiate, I mean the small changing in the slope, it will be equal to f and then you dash like a, or we say like f dip a or f prime a whatsoever, okay, it will be equal to limit of fa plus h minus fa and divided by h. And after we simplify this, we're going to let our h approach to the 0. That's the direct method. For example, let's say if I have t right here, ft equal to t power 5 plus 6t, and phi f dip a, and what is going to be? We once know that our f dip a, it will be limit of fa plus h minus fa divided by h, right? And our function is t power 5 plus 6t. Now we're going to change the function from t to a. Now you have a plus h power 5, right? Because we want to find like not only fa but a plus h, right? Then a plus h power 5 plus 6a plus h and minus the value of the previous function, which is a squared minus a to the 5th plus 6a divided by h. Simplify all terms. Use binomial theorem or whatever theorem to expand them. Now you got this. The term with the h and then the degree 5 and then minus a power 5 plus 6a. Simplifies it one more time. You're going to take h as the common factor and we cancel the h. You will left only this part. Okay? Now, after we left only this part, the slack is already cancelled. You take the limit h to be 0. If we take the limit h to be 0, this is 0, this is 0, 0, 0. Finally, you left only two terms. 5a power 4 plus 6. This is how the differentiate formula come. Okay? But if we use this like all of the time, it's going to be a bit messy because the function will be large. And also we're going to deal with like binomial theorem. It's just too hard for that. Okay? Then I'll provide you another one method. Go to the page 60. Oh, welcome back. Why too fast to come back? Huh? Right. Oh, welcome to the class if like that. มาเราก็นั่งอย่ามาโมกันได้ปะดี Okay. Derivative of the functions, okay, from dot limit f dip a, okay. This time if we give you functions like y equal to fx, the way that we doing that, we call differentiate of the function. We're going to do the differentiate of the functions. Write it down like this. We have y equal to fx, right? If we want to find differentiate or derivative of this function, we write it down like f dip x or y dip or the full term dy by dx. It means you going to find the differentiate of the function y compared to the x. It means we're going to like use x to be the number that we go into substitution like that. Okay, this is the way we write them down. Normally, I really get used to this one y dip and here the full form d of fx d by dx. Okay, d by dx we call them like differentiate operators. Now, how are we going to deal with that? The way that we're doing that, if you use the limit, it's going to be super long like this. Okay, if you use the limit theorem, because we need to like set the function to be x plus h divided by minus fx and divided by h, right? But if we use the basic rule of the differentiate formulas, it will be look like this. The first formula, it's right here. Before we doing the first formula of differentiate, let's take a look at it. The basic differentiate form, if you write it down just one time. F dip x just one time. Okay, this is called the first derivative of the function. Alright, you may write it down like this or like this or like this or like dy by dx. But if you're looking for the second derivative of the function, you just like take dip another one time. It will be like f dip x or d power 2 fx by dx square. But it doesn't mean that it's equal to like square, okay? But it's just the way that we write it down at a differentiative, like double times. welcome back. Set it, no talk. Okay. Then you can do it until like infinity dip. Okay. This is the way we write it down. But take a look at the theorem, the first theorem of the differentiate. The theorem 1, if we have the function, and now the function contains no x in it, but equal to the constant number. F div x, div the constant number will be equal to 0, like always equal to 0. For example, if you have fx equal to 6, f div x will be equal to 0. Why it's like that? Because when you write it down, the differentiate form, like the full form, f div x, it will be like d6 by dx. And in here, we have no x, right? It's just number 6. Then it turns to the 0 right away. Okay? Or else if you have, let's say, if you said your fx equal to a, let's say like that. Fx equal to a, when you like div one time, f div x going to be div a by x. But we have no x in here, 0. Okay? It will be look like 0. That's the first rules of the differentiate or the derivative of the function. But if you're not going to do like this, just remember that the changing of y-axis over changing of x-axis is like we finding the slope for the differentiate. And you can finding the slope instead of doing like this with the function. Okay? And take note first. All right. The theorem number 2, fx equal to x to the power of n, and n is not equal to 0. When you do differentiate, you dip it one time, it will be equal to nx to the rest to the n minus 1. Like we're doing the log this time. Okay? For example, if you have like fx equal to x power 6, okay, f div x is going to be here, take the number 6 right here. It will be 6x and the previous power, you minus 1. Like always, decreasing by 1. Okay. Now we have 6x to the power 5. That's going to be the answer. Alright. But if you write it down like a full format of this is going to be, we're going to say like this, like f div x will be dx power 6 divided by dx, right? We will look like this. And when you just change the function, like you do the differentiate of the function, this is going to be 6x power 6 minus 5 and dx by dx. Dx by dx would turn to 1. That's why the answer is 6x to the 6x to the 5. This is the full term. You will see that in our basic rule, we didn't say like d by dx, right? From the backs of the terms right here. But normally let you guys know that we didn't write it down because it will be dx over dx. It will be equal to 1. But if your dx is not dx anymore, it's be like dx plus 5 in the bracket and power 5, then we need to write them down. Okay? Okay. Or no matter what, it be the negative of the negative of the power, we can do like that. F div x going to be minus 6x power minus 6 minus 1. Then you have minus 6x to the power of minus 7. If you simplify for the full term, that must be minus 6 over x power 7. Alright, that's the second rule of the differentiate. Third rules of the differentiate, if you have constant number and multiply or multiply with the function. The way that we do dip it, you find the derivative of the function. You don't need to do the derivative of this number. Just take the function and let's multiply the numbers later. Okay, let's take a look. If our f(x) equal to 10x to the power of 6, this is will be f div x, it will be d by dx 10x power 6. 10 is a constant number. Just take it to the coefficient and then you dip only x power 6. You dip x to the power 6, you will have 10 times 6x to the power 6 minus 1 dx by dx. dx by dx turn to 1x power 6 minus 1 equal to x to the power of 5. 10 and 6, it's 60x power 5. Okay, that's the third one. Okay, I do another one example for you. For example, if I do have gx, let's say equal to 2x to the power of 4, like this. The way that you're going to dip g one time, it will be 2 dip x power 4 by dx, right? That's going to be 2 times 4, right? And then the previous one will be, the degree will be minus 1. And then dx over dx. These two cancel to be 1. The answer is going to be 8x to the power of 3. Okay, the fourth theory, if you merge 2, 3, 4 functions together, if your f(x) is ux plus or minus vx, f div x will be equal to, you dip u and then plus and minus with dip v. Okay, like we're doing two other functions. Like this question, when you dip it, the example 11, 3x power 3 plus 8. Okay, you dip 3x power 3 is plus dip 8, right? Then you will have 3x power 2 plus 0, right? Finally, you get 9x to the power 2. Okay? That's the thing. This theory will be look like this. If you got y equal to, let's say, x squared plus 5x plus 7. Okay? You dip x one time, it will be 2x, right? And if you write in the full format, full term, it's going to be dip x squared by dx plus 5 dip x by dx plus dip 7 by dx. Dip x squared, you have 2x squared minus 2x power 2 and then minus 1 dx by dx. Right? This is like dip x by dip x equal to 1, you get number 5. And the last term, dip the constant number, you get 0. Okay? Finally, the answer will be 2x plus 5. Okay? That we merge the theory together. Alright. This four theory will help you work on the next worksheet, and then we come back to the theorem 5. But today, let's complete the first 4 theory. All right. Now, please flip to the worksheet number 9, doing the basic dip, to the page 66. Right here. Okay, the worksheet 9, the basic dip. First question, what is the differentiate formula for that? You dip the constant number it will be equal to 0. You dip x to the power n by dx. You have n dip n x power n minus 1 dx by dx. Okay, you got the term. Okay, if you have two sort of function plus and minus, separate them. Do it separately for each term. Like a first question right here, if you want to look for y dip, would you have minus 2 dip x by dx plus dip 5 by dx, right? Constant number 0. dx by dx equal to 1. Y dip here will be equal to minus 2. In the first question, the answer going to be minus 2. Alright? If it be like a second question, this is almost the same. Yep, constant number becomes 0. Okay? This is will be what? We get minus 4x, right? It's minus 4x power 1 minus 1 dx by dx if we do the dip one time. And then minus dip up to equal to 0. The answer will be minus 4 for the second one. Okay, this is the process of calculus. This is we jump to the calculus 1 already, because the pre-calculus is going to finish with the limit. Okay, and the differentiate other function like this, it will be like, if you know how to use it, it's super easy to work with. Like if you're looking for the minimum value of the functions, like quadratic function, you want to find the minimum value, you can like dip it one time and you get the slope. Replace the numbers in there, you get the minimum. You guys don't need to remember the whole formulas of the math and physics if you know how to dip. Okay, because it's a relationship between y-axis and the x-axis. For example, is you have the equation of distance. You got the relationship between like the distance and speed and time, distance and time, something like that. And you can find the differentiate right here. It return to like the slope will be velocity, something like that. Or I dip in another one time, you get the acceleration. The third question. Y equal to 4x power 2 plus 1. If you want to dip it one time, this is going to be 4 dip x squared by dx, right? And plus dip 1 by dx. Dip 1, it will turn to 0 because it's a constant number, no x in it. And this is 4x power 2 minus 1 dx by dx. This is become 4x. The answer is 4x. Okay, normally if our function, like our x in the function, just like x squared, x power 1, x raised to the 5 like this, you don't need to write the full term like this. If you remember the formula, just dip it right away. Okay, but I write this one down because when it turns to the chain rule, I mean if your x is not x power 5 but it'd be like x plus 5 and then all power 5, the process of doing it is a little bit different. Alright, the question number 4, fx or y, you may say like y dip. Okay, y dip will be equal to like minus 3. If we don't write the full term, we can do like this: x power we dip, right? Minus 3 is the constant number, we don't need to do that. Okay, and then multiply 2 from x power 2, and then the previous numbers raised to the n minus 1, that 2 minus 1 and plus 0. The answer will be minus 6x. Like this. Okay. Same, almost the same with the questions 5. No matter what, we have 3 different terms. You want to find y dip, right? And your y dip going to be minus 4. Minus 4 is just a constant number. You leave it like that in front of the term. And then just start with number 2 from x power 2. We get 2. And then previous x to the power of 2 minus 1. Okay, and then you minus 5, right? And 1 time, yeah, x to the 1 minus 1 and minus 0. Okay, then the answer is going to be minus 8x minus 5. That's going to be our answer. Yep. ทำไมนะครับ คูณครับ ลืมครับ ดี for number 3 เนาะ I forgot to multiply the numbers. Okay. Rewrite this one once again. 4 times 2 and then x power 2 minus 1 plus 0. You get at x. Okay. It will be like that. The question number 6 is super easy to do, right? Take number 2 here. It's going to be 3 times 2 to the power x 2 minus 1 dx by dx. And plus 3, right? Times 1 x power 1 minus 1 plus 0. That's going to be 6x plus 3. That's the answer. Alright. But when it's become like a question number 7 is thing change here. Because if you want to do your y dip, the function y going to be minus 3x minus 5 and then the power of 1 over 2, right? 1 over 2. Now we go back to the basic formula of the differentiate a little bit. If you have the function, let's say, if you setting up the function like to be u's and v. Okay, if we get a function, let's say y equal to u to the power of n. Right, and you're gonna dip y one time, it's going to be n u power n minus 1 dx by dx. Du by dx, let's say like that. Right? Du by dx, you will see this term. Okay, u term. Now if it's be like a question number 7 is a little bit different to the previous one, because the previous one you have like x power 2, x power 1 right away. It's not merged in only one terms like this. But if it merged like this, you're going to set the term to be, let's say like that, like u equal to root minus 3x. Square root is 1 over 2. I'm going to say like that. U is minus 3x minus 5 to the 1 over 2. Just let the u term be this. And then we're going to dip it, right? If we dip this u to the power of 1 over 2. If you dip u to the power of 1 over 2, you have 1 over 2 u power n minus 1 du by dx, right? You get the terms like this, okay? And what we're going to do, 1 over 2, that we change u back. U is minus 3x 5, right? And the power, the previous one is, the previous one is, wait. Nu power n minus 1. Okay. The previous one is going to be, this is 1 over 2, right? U minus 1 like this. And then you're going to dip u once again. By dx, what does it mean? It means you're going to calculate this number. Okay? 1 over 2 minus 3x minus 5 to the minus 1 over 2. And you're going to dip this term once again. When we dip this term, it's going to be minus 3x plus 0. That's your answer. Okay. That's going to be our answer for this one. Let's take note this one. And then we can continue tomorrow. But let me explain this one once again. The basic thing of the dip is like you take when you do the derivative of functions with like x power 5, and you take number 5 multiply with the x, right? And then degree minus 1. But this time, because the term, our terms right here, it's merged. I mean the whole term to the power of 1 over 2. Now the thing that you could do, started from the differentiate formula, which is y equal to u power, and if you want to dip y one time, it means nu to the n minus 1 du by dx. I set the term u to be minus 3x minus 5. And now I want to dip the term. I want to dip u to the 1 over 2. Then the differentiate will be 1 over 2. I take it from the degree terms, right? And then multiply with the u term to the power 1 over 2 minus 1. And then dip u by dx, okay? This front term right here, we could calculate the number easily. But the back term, it's come with another one differentiate. You're going to do the the derivative one time, you have minus 3x. That's going to be your answer. Alright? Okay, no class attendance marking anymore because I already submit the one that get more sauce soon or whatever. No. Because more salt, it's not in the grade book. I don't like it. I let you take a test and then make it 0. That put in the paper. Right? Okay. But it's fine, everybody. We look fine because our pre-midterm score, mostly you get the full marks. And once again, post-midterm score, let your friends from Raudor come back. And then we start submit from like 16, 17, and 18. Okay? Because the differentiate, I think tomorrow we can finish it. And don't worry about Raudor because I already record the video for you. Okay, and I will upload to your Google Classroom. Thank you so much for today. The class dismissed.